yourself.
Well, I'm a student at UBC Okanagan and I'm studying education and I want to be a kindergarten teacher.
Great! Alright, now it's time to meet your kid. Everyone welcome Ryan!
You've been smart. Good pick.
Let's hope so. Alright, so let's begin with the first $1,000 question. Which of the following is not a prime number? Is it A, 1, B, 2, C, 3, or D, 5?
See, I remember this from Math 160 with Natasha, and I'm pretty positive it's C, 3.
Are you going to lock in that answer?
I'm going to lock in that answer.
Alright, Ryan has locked in his answer, which is very interesting because he has a different answer than you do.
Oh, no.
Ryan, what answer did you put?
I put A.
A, interesting. Now, is he right? I'm sorry, Becky, but he is right. You have just lost $1,000. Now, I'd like you to look at the camera and say,
I am not smarter than an elementary school teacher.
do you want to know why you went wrong? Let's go to our teachers, and they're going to show you why.
Hi, I'm Becky, and I'm sure you're wondering what a prime number is. Well, a prime number is a natural number that has exactly two different factors, itself and 1. A natural number that has more than two different factors is called a composite number. The number 1 is a unit neither prime nor composite. 0 is infinite, so it is a zero divisor. Would you like to know the history of prime numbers? Well, the ancient Greeks of about 2,500 years ago often get credit for being the first to study prime numbers for their own sake. Aristophanes came up with the Sieve of Aristophanes, proved many important basic facts about prime numbers which today we take for granted, such as that there are infinitely many primes. I know we already talked about this, but just to hit it home, I'm sure you're wondering, how many primes are there? Well, there are infinitely many primes. Shown by Euclid in the ancient times, if we multiply all known primes together and add 1, we obtain a number that is divisible by at least one new prime. Since this process can be continued ad infinitum, there is no end to a list of primes.
So, how do you identify a prime number, you ask? Well, a prime number is easy to identify if it's between 1 and 100 because any number that is even, so it ends in a 0, 2, 4, 6, or 8, is going to be divisible by 2 with the exception of 2 and 0. So any even number cannot be a prime number. And any number that ends in 0 and 5 is divisible by 5, or if it ends in 0, it's divisible by 10. So you can eliminate those numbers. As for the rest, any two-digit number, or any number that adds up to a multiple of 3, is divisible by 3. For example, the number 54, if you add up 5 and 4, it's equal to 9. 9 is divisible by 3, therefore 54 is divisible by 3. The number 81 also adds up to 9, which is also divisible by 3. Therefore, 54 and 81 are not prime numbers because they're divisible by 3. So the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll just look at those and try and determine which are the prime numbers. 0 we already know is a zero divisor. 1 is only divisible by 1, so it is a unit. 2 is only divisible by 2 and itself, so therefore 2 is a prime number. 3 is only divisible by 3 and itself, also a prime number. Now the number 4, we know that 4 is an even number, therefore it is divisible by 2. So this is a composite number, not a prime number. Number 5, only divisible by 5 and itself, therefore it is a prime number. 6, again, it's an even number, so we know that it is not a prime number. 7, also a prime number because it is only divisible by 1 and itself. 8 is an even number, so we know it's a composite. And then 9. 9 is divisible by 3, so we know that that's not a prime number. And same with 10. It's an even number, and it's divisible by 2. And it's also divisible by 5. So it is not a prime number either. So in the numbers between 0 and 10, our prime numbers are 2, 3, 5, 7. Aristophanes came up with a method called the Sieve of Aristophanes, and that's where he would write out a list of numbers with which he was trying to find the prime. So if he was trying to find the prime number of 100, he would write out all the numbers between 1 and 100. We'll just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 20, just to give you an example of what he did to figure out the prime numbers. 19, 20. So first off, he knew that 0, 1, 2, 3 was, and then he knew since 2 was a prime number, every second number would not be prime because it's divisible by 2. So we eliminate 4, 6, 8, 10, 12, 14, 16, 18, and 12. Next, since we know that 3 is a prime number, we're going to eliminate every third number. So 3, 6 is already eliminated. 9, 12, 15, 18, and then it would be 21. And then the next one we know is a prime number is 5. So we're going to eliminate every fifth number, which has already been done. So the numbers that are left over are going to be our prime numbers for the sieve of 20. 1, 2, 3, 5, 7, 11, 13, 17, and 19. That is how the sieve of Aristophanes did it, but it's very long and tedious. Okay, so say we have a bigger number like 243, and we want to know if that's a prime. We're not going to use the sieve method because that would take way too long to write out all the numbers between 1 and 243. So what we do is we take the square root of 243, and that equals, we know that it is roughly 15. So what we're going to do is we're going to try dividing 243 by all the prime numbers up to 15. If you'll remember from previously, they were 2, 3, 5, 7, 9, 11, 13. There was more, 17 and 19 were included, but they are above 15, so we're not going to test them. So now, dividing 243 by these numbers is going to give us, is a lot simpler and a lot faster than the sieve method. So, if we go 243, well, we know it's not going to divide by 2 because it's an odd number. 243 divided by 3. If we use the method previously described, 3 plus 4 is 7, plus 2 is 9. 9 is divisible by 3. Therefore, we know that 243 is divisible by 3, therefore 243 is not a prime number. For bigger numbers, that's what you're going to want to do, is find the square root and then all the primes up to that square root number. It's a lot simpler and a lot faster to just divide by a couple numbers. If your number does not divide into any of the primes evenly, it has to go evenly into a natural number, then you know that it is a prime number. Next, we're going to look at the prime power representations of a number. So that is how to find the number of primes that go into a certain number. So, to do this, we're going to use a method called the factor tree. What your goal here is to take a number and divide it into, it doesn't matter, because a lot of numbers have multiple factors. So you divide it into any two factors and keep going until you get to the lowest prime number. So we'll start with the number 18. 18 is divisible by 2 times 9, are both factors. 2 is a prime number, so it can stay. 9 can be further divided by 3 times 3. Now, 3 is a prime number, 3 is a prime number, and so is 2. Therefore, 18 in its prime factor is 2 times 3 times 3. Now, this can be tidied up a little and be written as 2 times 3 squared. If you try it on your calculators at home, you'll find that 2 times 3 squared is equal to 18. Now, if you were to do this another way and say 18 is also the same as 3 times 6, well, you're going to get 3 is a prime number, 6 is divisible by 2 times 3. Hey, this is the same answer as we had before. A factor tree can be used in almost any case with almost any number, and it will give you a list of the primes, and then you group them together. That's the easiest way to find the prime powers of a number. Now it's time to test you folks at home to see how well you've been listening.
Which of the following is a prime number? Is it A, 63, or B, 61?
Alright everybody, time's up. If you guessed B, then you are... Next question, hope you're ready.
What is 0? Is it A, a prime number? Is a zero divisor? Or is it C, a zilch number?
Alright everybody, time's up. If you guess A, you are completely wrong. If you guess B, then you are right.
Yay!
Becky explained this earlier and I hope that you were paying attention. Alright, next question. What is the prime power representation of the number 12? Is it A, 3 times 2 squared, B, 3 squared times 2, or C, 6 times 2?
Hint, draw a factor tree. Go!
Alright, time's up. If you guessed 3 times 2 squared, you are correct! Yay! Alright, last and final question for those of you who are still with us watching at home.
What is a composite number? Is it A, 1? Is it B, 6? Is it C, 3? Is it D, 7? Is it E, 2? Or is it F, 13?
Alright, time's up. If you said the answer is B, you are correct.
Thanks for watching, guys.
Tune in next week for more fun math facts.
But the princess,
As Becky mentioned earlier, the SIVA...
Hi, I'm Becky, and Tess. Which? Oh, okay, which? I always many miss. Oh, crap.
And you don't want to write out all the numbers between 7 and 700. 1 and 700. Is. And then you need to go and look at the board. Brett.
Oh, okay.
Yeah. Which of the following is not a...
I remember this from Math 60 or 160. Math 160 with Natasha. What are we doing now? Oh, okay.
Thanks to all of you who are watching.
What are we doing?
No, we'll just keep going. Keep going. We'll edit it out.
Okay, so what are we saying? Thank you for watching. Or did you go ahead?
You start and say...